All right. We're going to talk about growth and decay models. And by models, this is our real life application.
Like word problems?
Word problems.
And we just did that?
Nah. We've only graphed. Today we're going to talk about how to solve, okay? So we have this model that we use. And I kind of need to tell you what all these variables are. The first one is my growth model.
L plus
1, like the number 1. And the second is my decay model. Now let me tell you what each variable is, and then maybe you can tell me why the first one's growth and why the second one is decay. All right. A is going to be my, if y'all want it off. My initial amount. Okay. R is my rate. And whenever I'm talking about rate, I'm talking about how much it's growing or how much it's decaying each year, okay? The only deal is most of the time this is given to you as a percent. You have to change it to a decimal. How do you change a percent to a decimal? Left twice. Left twice. I'm glad you're so excited about it, Shami. T is my time, and unless otherwise specified, most of the time it's in years.
Why does that look like a plus?
It's a T.
Oh. It's up a little bit.
What may do? Now, think about this. Why do you think that the first one is growth and the second one is decay?
The minus and plus. The
minus and plus. A rate's a percent. If it grows 25% each year, then 0.25 is my rate. If I add 1 to it, I'm at 1.25. If I subtract 1, I'm at 0.75. So I'm greater than 1 versus less than 1 when we were talking about our... That's funny for what? Okay. Let's do an example where we use this. Not a shark today. Let's not do a shark today. Yeah, we did sharks yesterday. Let's say... Oh, excuse me. In 1996, that does not seem like that long ago to me, but it probably does to y'all.
I wasn't born then. I wasn't even born then.
There were... What year were you born?
2002.
Y'all were born in the 2000s?
Yeah. I think you're black, man.
I was born in 2000.
Do you think we were born in the 70s?
My sister wasn't even on then.
Clothing choices maybe were like that, but...
Wow, okay. In 1996, there were 2,573 computers. Computer viruses, I'm sorry, and other computer security incidents. During the next 7 years...
You're going to put computer viruses in it.
Well, I'm kind of reading you, though. Over the next 7 years, the number of incidents increased 92%. Increased. Increase would keep me in that it's what? Growth.
So, 1996.
How many computer viruses were there in 2003?
I don't know.
Okay, so you plug it into the equation.
What you did?
I'm plugging into this equation. Okay. So my initial amount or what I started with. How many did I start with?
1996.
In 1996, there were 2,573. So 2,573. That's my A if I were graphing it, right?
Yes.
My B, 1 plus, what is my rate?
0.92.
0.92. There's my B.
And And time.
So if I just wanted a general equation just to graph, my variable here is my time, right? So I could put an X here for my time. But since I asked you in 2003, then I need to replace this with 7.
So if it doesn't ask you for X.
Sometimes I'll ask you to give me a model, which a model would be with the variable in it. And you need the time is what's varying on everything. So that's your variable. So now put this in your calculator.
Oh, that's what the 7 come from?
This, by the way, is my growth rate together.
Is that a 1 or no?
1. So on your calculator, 2573 times 1.92 raised to the 7th power.
So 2573 times 1.92 or put parentheses.
What is it, Sam?
247,450.
Approximately that many computer viruses in the year 2003.
What's
Um,
that? Is that X
Where?
in front of the 247?
Approximately. That it doesn't equal, it's
No,
approximate.
but why does it look like an X?
You talking about this?
Yes.
It's just approximately. So, exponential growth, a lot of times, I'm trying to think of some situations. Population is usually modeled exponentially with exponential growth.
What about interest?
Let me tell you this little story. This is, I don't know why I remember this every time. So I think I've told most of y'all before that Mr. Matthews taught me in high school.
Did he really?
He did. He taught me AP Calculus. And for some reason we were talking about growth and decay in calculus, and I can't remember why, what exactly we were doing. But the way he taught us, or the example he used with growth, was the bacteria on your teeth and in your mouth
Stop.
grows exponentially.
Ooh.
So let's say you brushed your teeth before you went to bed, and the decay or the bacteria on your teeth double every 30 minutes. Okay? Think about the bacteria that's on your teeth in the morning, even though, because you can't brush away 100% of the bacteria, right? And so what doubles 1 minute turns in, and it gets really big really fast. And then he looked at us, he goes, so imagine if you didn't brush your teeth at night, how much bacteria would be in your mouth the next morning. And I don't know why that's what I think of every time I think of exponential growth now. I think about
Thanks, Mr.
gunk in your mouth. You're welcome. So if anybody ever asks you for an example of exponential growth. All right. Let's talk about decay. Can you think of some situation where you would use decay?
When you're shrinking.
A balloon.
As you get older.
A balloon, maybe losing air, deflating. What else can you think of?
Value.
Value, that's probably what I would think of. Value of what? Like a car. A car's a great example because they say as soon as you buy a car and drive it off the lot, it decreases in value, right? And it continues to decrease and continues to decrease.
You buy the older piece of value.
So let's say you bought a car brand new for
$20,000.
$20,000.
What can I call it?
I don't know.
A Lambo.
A lamp for $20,000.
A
And let's say that you ask the car dealer, because you just know these kind of things, what the depreciation rate is. And he says, well, this car depreciates at 5.7% per year. And you say, I got to think about this because I want the car to last me through high school and through college. So I want to make sure I can still get some money back for it after all that, assuming I haven't wrecked it or anything like that. That was my story in high school, but anyway. Oh, terrible, terrible. So y'all are what, sophomores?
Junior.
Okay, we're going to go with the majority here. All right, so 2 more years of high school, 4 years of college. You want to count grad school?
No. No.
Let's cut the difference. We'll count 2 years grad school. Okay. So let's say 8 years. I want to know in 8 years, because you know when you get finished with college, you're going to be broke as a joke.
No, it ain't.
Says who? You'll be broke all the way through college till you get a job.
So what are we gonna be at like after we get out of college? Mama?
Well, you'll get a job, but
What we gonna
you be in debt. All right, let's say 8 years.
No, I don't wanna be broke.
You get a job. You go to college so you can get a good job, so you
know
won't
that,
be
but
broke.
at the time I'm gonna be broke. I'll be looking like lousy.
5.75. What's that dot?
All right, so the question is, what's this car worth after 8 years? Okay, so I'm going to start with my initial amount times 1. This time it's minus because it's depreciating. Change that percent to a decimal.
0.057.
Yes. Raised to the,
I like this.
okay, we haven't got to the money yet.
Money. If it's just plugging stuff into an equation,
How much is the car worth?
I can't put it in.
12,506.
Hey, that's pretty good. I'd say if you drove it for 8 years and you still got $12,000 from it, that's pretty good.
That is really good.
Yeah, that was made up off the top of my head. They probably depreciate like 20% a year.
Yeah.
All right, so that's growth and decay models. Does that make sense to everybody? Let's move on to money, everybody's favorite then.
That's the best feeling in the world.
All right, so you go to the bank. Okay. You should be good at this, Tanner.
I know.
You have a lot of family members in banking. You go to the bank and it's your birthday and you've got $500. I don't know. I never got that much, but anyway. Okay, and you want to take it to the bank, okay? And you want to put it in your savings account. So here's my question to you. When you take money to the bank, they pay you interest, right?
Yes.
Okay.
It's usually really small.
It's very small, but let's say you take that $500. Let's just say they do it every quarter. And so after the first 3 months, you make $5 on your $500, which is that's a lot because banks don't do that. Okay, but let's say, so you've got $505 now, right? You're not, let's just say it sits there stagnant, you're not putting anything else in. The next time that they calculate interest, are they calculating the interest on your $500 or are they calculating the interest on $505? The $505, right? That's what we call compound interest, okay? Compound interest is when you make interest on interest. So in other words, you didn't put that $5 in there, but they're still giving you a percentage of that $5. Does that make sense? Okay, so interest on interest. So we have some formulas we use to calculate how much money we would have left, okay? Now, one thing you need to understand is they can compound different numbers of times per year. And in our equation, we're going to have a variable called n, where this is going to apply. But if they told you that it was compounded quarterly, how many times per year? Four times. How about monthly?
12.
How about daily?
365.
Okay, and we could keep going. Weekly? You said weekly? 52? Okay, so we're going to use this formula to see how much we have. And so here's the formula. It's very close to the other, but it's got a little bit more. My A is still the same. That's how much I start. That's my $500 I walked into the bank with for my birthday. 1 plus. I still have a rate because if you go to any bank, they're going to tell you what the interest rate is. But this time I have to divide this rate by n. This is my n. How many times is compounded per year? Okay? And my exponent this time, instead of just being t, is n times t. Y'all with me?
Yeah.
All right. You got your $500. What's your favorite bank, Tanner? What's the bank? Everybody works at First Palmetto?
My brother don't work there, but
Oh, okay.
my mom does.
Okay.
Bank of America.
My mom works
Saved.
Let's say you walk into First Palmetto with your $500 in hand. And because you know so much about interest now from your Algebra 2 class, you say, excuse me, can you tell me what your interest rate is on your savings account? And they say, okay, sure. It's 2.3%. That's really big too. It's point something actually if you go in there, if you want a real life, it's like point something, right?
Mm-hmm.
Okay. It's 2.3% and you go, woohoo! How many times is that compounded a year? And they say, oh, it's compounded. What do you think? Give me one. Quarterly? I heard quarterly. Again with my 8 years, because that's when we'll be done with all of our schooling, how much money has that $500 grown to after my college? After 8 years. Y'all plug in. I'm going to plug in up here while y'all plug in. These are calculator problems.
Right. So the things mean the same thing?
Yep,
What is N?
yep. N is the number of times it's compounded per
Okay.
year. So this list here, these are your N. Be careful if you're entering it in, because you got a lot of fractions here.
Don't we just do plus 0.23 divided by 4?
2, 3.
Yeah, I would and add 1 to it. If you put it in all at one time on your calculator, you're going to need a separate set of parentheses around this because it's a fraction. But I really want to make sure everybody can come up with the same number on their calculator.
$600.
Even?
No.
600.69127. So.
Wait, what?
600.69.
$600
Yeah.
and 69 cents. I highly doubt anyone over 8 years is going to pay you $100 for sitting in there. But for the sake of an example, did everyone get this on your calculator when you plugged it in? Okay. Yeah.
0.69. Why is there a line
What line?
underneath 69?
That's just how I do money. We good? We all on the same page?
Yes.
Okay. Let's take it one little step further, and this is all I got left for you, I promise, besides your pre-quiz for tomorrow. Let's say that you're compounding. We talked about how many times it's compounded per year, right? And it could be compounded monthly. It could be compounded weekly, daily, and that's good because that's what I want. That's what I'm trying to get you to. Hourly. You could calculate how many hours are in a year. Tanner said minutely. Sam said secondly. Huh? Nanosecondly. The point that I'm getting at is the closer and closer you get to all the time, like all the time, you get really close to a certain number. Okay? E. Here's where your E's come in, okay? If you could compound continuously, and you would think it would make a whole lot of difference, but it really doesn't. But if you could compound continuously, your rate, your 1 plus R would be E. And then you've got raised to the, this is PERT. This is the most real to life, yeah. This is the most real to life formula. The P is your A, but everything else is what it was.
Wasn't it fair?
It's just always been PERT. I don't know. PERT and Ernie.
That looks like a name.
PERT's the shampoo.
What's the second word? Initial.
PERT plus.
AMT.
Initial amount. Okay. So if I took that same example over the same 8 years and I did $500, E, what was my rate again? 2 point what? 3?
Yes.
Times 8 years. Now what's the difference in how much you made?
Wouldn't that be a lot?
I don't know. No, it won't be.
A little bit more.
A little bit more. What is it? 600 point,
601.1.
Yeah.
point 01 or
1
point
cent.
1? 01 or
Well, there was
10?
originally 0079, so I just wanted 01.
So 01. Okay. If you had gone back, and I'm gonna come back here to this formula, and you had kept increasing this N to 365 to however many hours, the number that you would get there would get closer and closer to this number because it's approaching that PERT value. So you have to read the problem carefully and see if it's compounded a certain number of times per year, then you would use the big nasty long formula like this. But if it's compounded continuously, then you're going to use PERT.
Wait, how do you know the difference?
The problem will literally say you have $500 deposited into an account. If the interest is compounded continuously, how much do you
So
have?
this is the continuously.
But if it says it's compounded quarterly, then you
I
know
would
to
want
use
it
the other
quarterly, though.
formula.
Because you get more
Okay.
money.
Right. All right.
You get like more